Yes, sir. How are you doing?
Okay, good evening, everyone. Let's start today's last revision session from my side. So, welcome all of you for Aspen Plus Simulation Software Basic Course for Beginners. Welcome to all of you for today's revision session. So, in today's session, mostly we will be only discussing some multiple choice questions. I hope this is the same pattern that will be followed for your examination. Are you guys given any on which date your exam is being occurring?
The
Are you
27th of April.
27th or of April, and is it online or offline?
It is computer based.
Okay, computer based, and they are not going to provide software, right? Or I don't think they are going to.
So
It
no
will be
idea.
just, I don't think they will provide software for calculation. So in today's session, we'll just, I have prepared so many, around 80 small multiple choice questions. So let's try and discuss them. Some of the questions we have already discussed during my session, and many of the questions are new. But let's start with zero. We'll just discuss and we'll discuss answers and methods. Okay, so this is the first question. Uh, just a minute. I have started recording, right? Yes. Yes. Okay, so let's start. Uh, I hope my screen is visible to all of you. So this is the first question. For a simulation to run, the degrees of freedom should be equal to what should be the value of degree of freedom? Anyone?
Sir, zero.
Yes, it's zero. Can anyone tell me what if I have degree of freedom one or two? Can I run my simulation? Will it allow to run?
It will show as error because some parameter will not have been defined which is necessary for calculation.
Yeah, it will show required input incomplete. And let's say, and one more thing, where are we defining this degree of freedom equal to zero? Or indirectly, how are we defining degrees of freedom is equal to zero? How Aspen is taking care of this thing, degree of freedom? Can anyone tell me?
Sir, whenever any feed stream we have defined or any reactor or operator that we have defined, there is
Yes,
a circle uh, beside the name, and that needs to be green. And because for it to be green, all the
yes,
parameters need to be defined properly.
define. Okay, so let's say I have this, sorry, where did that go? Separator, not separator, columns. Let's say I'm using a red flag input. This is my red flag column. So here you can see that, let's say when I'm choosing no condenser and no reboiler. So see, these two values are automatically disabled. So we don't need these values. We don't need these additional parameters. So this is how degrees of freedom is taken care. Let's see if I am taking one reboiler and one condenser, then automatically these values are enabled. So this is how Aspen is taking care of degrees of freedom. So it will only allow when it will only allow for us to run when degrees of freedom is equal to zero. So this answer should be zero. Okay, the second problem. Which of the following is not a correct approach for Aspen simulation? Sequential, equation oriented, combinatorial, or model set is not a correct approach. Anyone? Okay, what is sequential modular approach? If you remember your lecture one or lecture two, lecture one mostly. No,
I think zero.
zero. What zero? First problem is done. I'm talking about second problem. Second question, not problem. Which of the following is not a correct approach for Aspen simulation? Sequential modular approach, equation oriented approach, combinatorial approach, or model set approach?
Sir, the answer is model set approach.
Model set approach. What is sequential modular approach? Aspen, it's
Sir,
basically a
we
steady
have to
state
follow particular
simulation.
order.
Yes, please say.
Sir, we have to follow particular order and of operation, and if that operation of order is not perfectly calculated, then the answer will not be correct.
Yeah, it will simulate in particular sequence and it is basically a steady state. It will give steady state solution. In equation oriented approach, we customize some, it is some customized based. We give some equation. It is and it is more than it's a dynamic, it's for dynamic simulation. And combinatorially something like we are approaching steady state and we are first, we are not at steady state, we are trying to achieve steady state from equation oriented and then it is in steady state. These combinator, there is nothing called model set approach in Aspen Plus. So answer should be answer D, model set approach. Okay, so let's move ahead for question number 3. Lee Kessler property method is a cubic equation of state-based model. Is this true or false? Okay, first, what is Lee Kessler property method? Okay, don't, even if you don't know what is in terms of Aspen in your thermodynamics, you have studied Lee Kessler model. What is Lee Kessler model? Okay, I will tell you. Lee Kessler model basically gives values of compressibility factor Z as Z is equal to Z0 plus omega into Z prime. So Z0 is ideal gas compressibility factor, omega is eccentric factor, and Z prime is deviation from Z value. So from deviation from ideal Z value. So that is how we can get value of compressibility factor. And then we can use equation PV is equal to ZRT. So now tell me, is it equation of state approach or not? From the story that I told you.
Sir, is it false then?
How is it false? See, I am saying that in Lee Kessler property method, Z is calculated as Z is equal to Z naught plus omega into Z prime. So this Z value we give input in PV is equal to ZRT kind of equation. So this is equation of state based
Yes, sir,
model,
then it is
correct?
true. Yes,
Correct. So it
yes,
is
sir.
true. So please remember Lee Kessler. It is Z is equal to Z naught plus omega Z prime. Okay. The next question. The second outlet stream of a mixture unit in Aspen is called. What is it called? Okay, let's go to Aspen unit. Aspen plus. We have one mixture unit. So let's add mixture. So mixture, we have two streams, right? This first is actual product and the second one is water decant for free water or dirty water. Okay, so what should be the answer then?
Decant stream.
It's a decant stream. That is generally basically based on some density. So you will not be, I assume that you will not be getting this Aspen window. So you should know these easy answers. Okay. Okay, then question number 5. As per norm, which of the following free water methods should be used with SRK property method in Aspen? Is it ideal, steam TA, steam NBS, or CSOP 0 property method? This is mentioned by sir in class in one of the lectures, I remember.
I think Steam NBS.
Yeah, it should be steam NBS. So steam NBS is basically, I forgot my notebook. I have written this. It is based on some, wait, let's check this on Google. Uh, Steam and we okay. Why are we going on Google? We have Aspen help window. Okay, let's search there only. It is used from some 298 to long temperature range and up to 1000 bar pressure, and it is based on 1974 some steam property table. I forgot that year. Uh, I don't think if okay, it's searching. Okay, Steam NVS. Yeah, 1984. It is based on 1984 Steam table. And yeah, this is the temperature 273.15 to 2000 Kelvin and maximum pressure is 10,000 bar. And this NBS method is recommended for the use with SRK and these other property methods. Okay, so you should remember this whenever we are using SRK equation of state for pure water and steam, then we must use steam NBS as a steam property method. Okay, I hope this is clear to everyone. Okay, next question. A decanter is used only for liquid-liquid separation. Is this true or false?
I think false.
It is false. Why it is false? What does decanter do? Your answer is correct. What does decanter do? Who told false? At least tell. I guess Kalim
I
told.
told I told
Yes.
false.
Yes. Why do you think it's
Actually,
false?
you have all you have already showed earlier of a mixer stream, I think, in which one stream is as outlet and the second was as water decant.
Yeah. So is it liquid or liquid vapor?
I think it was
Decant.
liquid.
Yeah. So answer should be true or false. The question is decanter is used only for liquid-liquid separation. So it should be true or false. It should be true, right? What does
Yes,
decanter do? Decanter separates two streams based on the difference in their densities. Let's say I want to separate water oil in my operation, so I can use decanter. So how does it separate? Water phase is heavier or lighter than oil? Density is different, right? For both the liquid and
Lighter than oil.
yes. So both have
Water is lighter.
yes, both have different densities. So based on that density, we can completely separate oil and water. So this decanter is not mainly, it is only used for separation of liquid based on density only. Okay, so this was the sixth question. Now let's move ahead. Which among the following is not a valid option in flash type in flash specification of heater unit? So let's go to, does anyone know the answer or want to comment something and then we can go to Aspen window? Anyone? Sorry, I'm not able to.
Pressure drop correlation factor.
Okay. I guess everyone, all of these are valid options. So if we go to Aspen window and we go for exchanger, let's say I'm using this heater. And if I go to this flash type, so in flash type, in set of temperature, we have temperature, duty and degree of superheating from these three degrees of superheating, duty and temperature we have. Then in pressure kind of this part, we have pressure, duty, vapor friction and pressure drop correlation parameter. So all of these are valid option. There is no option that is not valid. Okay. So is this clear? We can give all these inputs. Like if I give temperature, then I can give any of these pressure, duty, pressure drop correlation, any value. Okay. Let's move it. Heat X unit cannot perform pressure drop calculations. Is this true or false?
True.
How?
Like I was going through your previous videos there, I got the question and answer
Okay.
there.
Which video? Okay,
Somewhere around first or second week.
let's say this is heat X unit, right? Who taught this? Who gave this answer as false? I just want to know.
Rohit. Rohit.
Rohit, no, whose video was there?
I think your assignment only I was going through. Like
Previous year
following
or this year?
this year only. First 2 weeks I think you have covered this one.
Okay, so this is heat X unit. In heat X unit, these are the specifications we need to give. Okay, and there is an option of pressure drop, so it can calculate pressure drop from geometry. It can calculate. Why? I don't know why it cannot perform. It can perform. We can calculate. You see, you can see from here pressure drop. Outlet pressure either we can see or it can automatically calculate these values from geometry. Cell side and tube side. If you remember the design, theoretical design part, you need to have some tolerance for pressure drop. So it calculates pressure drop. From here only we can see. Was that assignment, this year assignment question or previous year? If you can, according to me, it should be false, right? Heat unit can perform pressure drop calculation. Is this clear?
Yes, Brazil.
Okay, let's move ahead. Okay, I guess this photo is not clearly visible, but is it somewhat a bit visible or not? So
Yes,
in
sir.
this photo, we are given some temperature. One stream, S1 stream, it is entering into some heater or cooler type of some exchanger. From there, it is entered into reactor. So we can see that temperature. This is temperature in Celsius, pressure in bar, molar flow rate, and molar vapor fraction is given. So let's see what question is asked. The question one is the vapor flow rate in feed S1 is. We are asked vapor flow
261.
rate. So what should be vapor flow rate?
261. 261.
How 261?
300 into 0.87.
Yeah, 300 into 0.87. So that will be the answer of vapor flow rate. Then second question is pressure drop across the system is. What is the pressure
0.
drop across the system? Yeah, it's 0. It is entering at 35 and leaving at 35. So the pressure drop is 0. The last question is the block B1 is a cooler. Is this true or false?
False.
How?
The temperature is
Temperature
increasing.
increase.
From 230 to some 376 value. So we can say that it is not a cooler, it is a heater. Okay. Guys, just give me a minute. I will just stop sharing my screen. Just a minute. Okay. Let's move ahead. My screen is visible, right? Okay, so let's check the question number 12. Which among the following is not a standard unit set in Aspen? It is English unit, English Celsius bar, metric Celsius bar. B. English unit with Celsius and bar. Okay. We can see that from here. Yeah, you can see that it is metric Celsius bar, is metric unit and English, British units. Okay. Okay, so let's move ahead. Which of the following is not a valid search criteria to find compounds from database? Name,
Viscosity.
molecular weight, boiling point, or viscosity? Okay, what is the answer?
Viscosity.
It is viscosity. Who is this? Can you guys do one thing? Whoever is answering, can you please tell your name?
Rohit.
Okay, I don't have to switch my window. That's all. Okay. So Rohit, we can see from from here. So we can see that we can find from name or alias, then molecular weight and boiling point. We can't calculate based on this viscosity. This next question. Which of the following is not a valid tab in component specifications? Polymer,
Petroleum.
petroleum, non-conventional or enterprise database? Which one?
Petroleum.
Who is this Rohit again, I
No,
guess?
no. It should be polymer. Polymer. Sorry for that. Sorry. Polymer.
Yeah, you can see that in this window, there is petroleum, non-conventional enterprise database. So
It should be polymer.
there is no polymer. Okay. Next question. Okay, what is the full form of Aspen?
Advanced engineer, advanced simulation process engineering.
Advanced Simulation Process Engineering, sir.
Yeah,
Let's check. It is Advanced System for Process
system.
Engineering,
Okay,
not
advanced
simulation.
system, not simulation.
System. Okay, be careful.
Mhm.
Okay.
System.
Next question. Aspen Plus is available for which operating system? It is
Windows.
very only it is available for Windows. Which approach is used for Aspen Plus simulations? This we
There
already
are
discussed.
sequential,
Yes.
modular
Sequence
sequential,
modular.
sequential.
Okay. Then the maximum number of characters that can be assigned
Eight,
for making a component is
Eight.
8 or
eight,
9?
eight.
8. Okay. We can see here, let's say
Eight.
I'm writing. Let's say I'm writing isobutane 1, 2, 3, 4, 5, 6, 7, 8. I won't be able to write. There are only 8 characters. Okay. Let's move ahead. So we have completed T18. The flash block in Aspen Plus is used for
Material
distillation,
Distillation.
balance.
equilibrium.
Well,
Sorry.
material balance.
Okay. Okay. So wait. I just need to know who is saying distillation. Someone first told distillation.
Sir, I said distillation.
Okay. Then someone said material balance.
Rohit, me myself.
Okay. Okay. Dhruv, first coming to you. Why do you think we this flash unit is based on used for distillation?
Sir, it is for located in the separators only along with the separators, and so I think according to that.
Okay. Rohit, you are saying material balance. Why do we need to do material balance? We need to go for flash unit.
We have flash 2 and flash 3. Flash 2 is for vapor liquid and flash 3 is for vapor liquid.
But what is
So
that? Do we use for material balance?
not exactly material balance, but the options
Okay.
which are present there, uh, I see only material balance as a valid option there.
Okay. Let me ask you one question. What do we do in flash?
Hmm?
What do we do when we are flashing something? What is happening? You told that
We
there is one vapor liquid and there is one vapor liquid. So
yes, yes.
what is actually happening?
Uh, we are separating based on boiling points, like
Phases. No, not boiling point.
not boiling
It's
points,
not a
like
separation. It's not exactly separation. It's a phase separation.
phase
So
separation. Yes,
it
it's a
won't be
phase
like,
separation.
yeah, it won't be exactly like that. Okay, so whoever attended my first lecture, my first session, so in flash calculation, we plotted XY, TXY diagram in first session only. So what kind of diagrams are those? XY diagram, TXY. We calculated bubble point, dew point.
Yes,
Anyone who joined my first lecture. So what is those values? Those are material balance or those are equilibrium based calculations?
equilibrium based. Like
Yes, those are.
Equilibrium.
okay,
Yes.
okay. When the first bubble forms
Yeah.
and all the quantity becomes into the
If
when
you
the first
remember,
bubble.
if you remember, we played with flash drum. We kept first some temperature and we told that we need vapor fraction is equal to 1. And we told
Yes,
that
yes.
liquid fraction is equal to 1. And from there
Okay,
we plotted TXY. Though that is first part that is not at all a distillation. Distillation is complete separation of components based on boiling point. Let's say I
boiling
want
point.
to separate ethanol water. So it is complete separation based on distillation. But flashing is, let's say I have 6 mixtures of hydrocarbon, let's say C2 to C6. So if we flash them, we can separate phases. We can just separate phases. Okay. Vapor liquid or liquid, or even we can't separate phases. The example is like, let's say I am entering some liquid and I am getting some liquid at bubble point or dew point. So that is not distillation at all. That is just equilibrium calculation. Okay, I hope this flash part is clear. Flashing means we are separating components, we are separating phases. I hope this question is again coming, so we will reply. Which Aspen Plus model is best suited for simulating ideal gas mixtures? Redlick Pong, Peng
Yeah,
Robinson, ideal or non-equilibrium?
ideal.
So what is ideal model for ideal gas mixtures?
Ideal actually takes into consideration of both Henry's and Raoult's law. So
Yeah, so what is that? I'm asking that only. What is that equation, if you know? For Raoult's law, ideal Raoult's law is y into p is equal to x into p set. But here we are talking about ideal gas mixture. So ideal means it is asking in terms of equation of state because it is just saying gas. So it should be p is equal to nRT. Okay.
okay, but ideal equation of state uh, EOS.
It is same yp equal to xp set, but here it's just asking about ideal, not equilibrium with some liquid. So why will we go for yp equal to xp set? Raoult's law we
Okay,
don't apply.
option will be C only here
Yeah,
in this option.
option is right, ideal, but I'm just elaborating what is ideal.
Okay, okay, yes, yes. Yeah, I require this type of elaborate explanations.
Yeah,
Yes,
it's
thank you.
it's it's written ideal gas mixtures. There is no liquid. So if there is no liquid, why will we have Raoult's law? Raoult's law is for vapor liquid equilibrium, right?
Actually, in when we see in the Aspen, what actually happens is that when you select the ideal, it actually
Okay, what is
considers
it
both.
writing? Okay,
It
let's see.
considers both Henry's and ideal. So that's the explanation which I have given.
Use both
Use
Raoult's law
both
and
Rolls
Henry's
and
law.
Henry's law. This is what I was
Okay, so
telling.
what is for ideal gas? PV is equal to RT. What do they write? I just want to know. Okay, they are considering this only, but I don't know. But and what is Henry's law? What is Henry's law? Okay, if you don't know what is Henry's law, just give me one example of Henry's law.
Henry's law is like sparingly soluble
See, I have
solutes
this
which will
soda
be
bottle.
present
I is this visible or
CO.
not? Soda bottle.
Yes, yes,
So is Henry's law here applicable somehow?
yes, sir.
If I
O2,
open
CO2, and
this, if I open
there will
this,
be
what is
some gas
yeah? So CO2 is dissolved in.
dissolved.
Luckily, I had soda right now.
Yes,
Okay.
CO2, O2, and other gas mixtures sparingly soluble in
Small
the
gases, yes, small gas mixes
small amount.
in small yeah, small amount, small gases in small amount, very small amount in some solvent. So here water is solvent, right?
Yeah.
Okay. The prop keyword in Aspen Plus is used to. Why do you when do we use prop keyword? I know what most of you are going to say. Please
Actually,
respond. Very easy
Aspen
questions.
has Aspen was stopped, like, or its license checkout error is coming. So I was not able to access Aspen right at this moment. But
Okay.
this is a very easy
Let's.
question. It
So
should be
what should
define a
be the
component.
answer? Yeah, it should be for defining a component, not for defining a property. Okay, so here if we go to this property set, we can define component, we can define methods, right? Right or wrong?
Yes, sir.
Yes. It seems that you guys are not prepared, or you are not, you are feeling shy to respond. I guess shy is not the actual reason. These are very easy questions. Just try to attempt. I'm not going to kill any one of you for wrong answers. Okay. Which type of block is used to represent a heat exchanger in Aspen Plus? Separator, reactor, HX or mixer?
Checks.
Checks.
HX, yes. It is HX heat exchanger. Name itself says the answer. Which thermodynamic property in Aspen plus is Aspen plus enabled
Gives
to
free energy.
calculate directly? Entropy, enthalpy, Gibbs free energy, or heat capacity? Someone told Gibbs free energy.
Yes.
If we
In the
check our
results,
yes,
in the
if we
results
check our
section, they
results
don't give.
part, we can see that there is no Gibbs free energy available. Okay. To specify a feed stream, okay, who is this? Lots of noise. Okay, wait a minute. I need to mute everyone. Okay, it's done. No, it's not done. Uh, okay. To specify a feed stream in Aspen Plus, you would use the block COMP stream or property.
Stream.
Stream.
We'll yes, we'll use the stream option to define the stream. If we go to here, Aspen, so these are streams. So these material stream we will use to define component. Should not define the component to define the conditions for stream. Feed stream. Very easy question. What type of file extension is used for Aspen Plus simulation?
BKP.
BKB.
Yeah, it's .vkp. Let's move ahead to 26th. What does the term flowsheet refer to in Aspen Plus? A document summarizing results, a diagram representing process flow, database of simulation parameters, or script for automating simulations.
Sir,
B. A
B.
diagram represents the
Yeah,
process.
it's a diagram representing process flow. Okay, now you should respond to this question. What is the purpose of flash block in Aspen Plus?
A option.
Option A, we separate our mixtures in two or more phases, right? Dhruv, is
That
this
question was a
clear?
bit tricky.
Yes, sir, it
Sorry.
is clear.
Okay, yeah, what were you saying, Rohit?
That question was a bit tricky. Equilibrium and that one was tricky.
Yeah, just be careful. Okay, so here the answer must be to separate a mixture into two or more phases, right? For that we use flash block, and here for flow sheet, if you want to see in Aspen, this is flow sheet containing blocks, or we can say this is kind of diagram, flow diagram. Okay, so we have completed till 27. What is the role of reactor block in Aspen Plus? Very easy.
Chemical reaction model.
Chemical reaction modeling. And what are the models in Aspen Plus?
There are total 7 models.
Okay.
PFR, CSTR, batch reactor. These are more of
Again,
rigorous type of reactors, and there are four basic models. Basic models include yield reactor, Gibbs reactor, equil reactor, and one
Arstoic.
more reactor,
Arstoic.
Arstite.
Yes. Okay. Which unit operation in Aspen Plus is used to separate components based on their boiling points? Through you will say,
Distillation.
sir, C.
Distillation column.
yeah, distillation is for separation of components based on their boiling points. Okay. What is the purpose of splitter in Aspen Plus? To separate components in mixture based on their boiling points, divide the process stream into two or more streams, measures the pressure of
B
stream,
option.
converts a liquid to vapor.
B
Divides the
option.
process
B.
stream into two more streams.
Yes, name itself says splitter, so it splits, right? Okay, next question. What is the purpose of a block in Aspen Plus simulation? To display information, to create a graphical user interface, to represent a unit operation or piece of equipment, or to execute a specific calculation.
A. To display information.
C. C.
C.
Okay, I have received two answers. Who's first? Let's go to first. Who said A? Just say it, it's fine. Who said
My
A?
option is C.
Okay, your option is C. Okay, now let's see. I am choosing this mixer block, right? So what is there in mixer block from option? It is representing unit operation, right? If we click on this block, we are supposed to fill some information. So what is this doing? This is representing one unit operation. Let's say if this is this distillation column, red frag model. So what is this containing? This is containing this is representing unit operation, right? So distillation is a unit operation. It is represented by this block. And when we click on that block, we are supposed to fill some input data for calculation. So the answer should be answer should be C, to create a unit operation or a piece of equipment. Now 32. Which of the following unit operations can be modeled in Aspen Plus? This is also very easy.
Heat
What should be the
exchangers.
answer? Heat exchangers, right? Now let's go ahead. In Aspen Plus, which unit operation is commonly used for separating components again? This is repeated. I did not notice.
Distillation column.
Distillation is separation based on boiling point. Okay. What is the purpose of reboiler in distillation column? Is it used to cool
To heat
vapor,
the liquid.
to heat liquid, to separate
To heat the liquid.
components, or to compress vapor? Yeah, we heat, we reboil. Reboil name itself says we are reboiling. We are again boiling it. So what do we boil? We boil liquid feed on the bottom part. Okay. And similarly, what is the function of condenser?
To keep
We
cool and condense the vapor.
Yes, we cool and we condense the vapor stream. What is the purpose of absorber in absorption unit? To heat liquid, to cool vapor, to remove gas from vapor, or to separate component based on their boiling points?
To remove gases from vapor.
Okay, to remove gases from vapor. So can anyone give me one example of absorption? Very famous example.
Water shift gas reaction.
How is that absorption? Who told this water gas shift reaction?
Rohit.
Okay, so can you explain how is that absorption? Hello?
I was just thinking like water gas shift
Okay.
reaction. Mm,
Can you just say what happens in a water gas shift reaction?
Water gas shift reaction, CO plus H2O gets converted to CO2 and H2.
Okay, so how is that absorption? Gas absorption? That is not gas absorption,
It's
right?
not a gas absorption. Yeah,
Yeah,
I think
I will tell very common. If someone has been into ONGC Hazira, this unit is there. It's CO2 absorption from natural gas using amine solution, monoethylamine or diethylamine, MEA, DE or TEA. So we are
yeah,
removing gas is a huge, natural gas is in huge quantity. We are removing we are
CO2.
removing CO2 from gas using using some using some
amines,
amine
amines.
solution, that is absorber. So here remove gases from vapor. So from natural gas we are removing CO2. That is very standard example. And if someone is going for some internship or hopefully in get job, I wish someone get job in ONGC Hazira. So there is this unit, gas absorption unit, and when you will enter in this ONGC, this will be the first unit that you will be taught.
Okay.
So this is gas absorption absorber. Okay. So next question, liquid extraction in Aspen Plus is preliminary used for separating
Extracting one or more
components,
components from liquid to other. C option.
liquid phase to another. Any example for liquid extraction? Any general example? I don't remember right now, but if any one of you remember.
Uh, I think in one assignment, sir has asked about 3 decantants in series and removing
What
the
was,
raffinate.
Acetone and water and
I don't
ethanol.
remember that.
yeah, I guess separation of acetone from water using ethanol, right?
Yeah, yes.
Okay. This is one of the example. There will be many example. Let's say I want to remove traces of benzene from water. Then also I will. Okay, let me ask another question. Let's say I want to. I already told the example separation of removal of benzene traces from water, and you guys told separation of acetone from water. So let's check what is boiling point of acetone.
62 or 68 degrees.
Acetone. Okay. Oh, it is minus 56. No, it is 56 degrees Celsius. Sorry.
It is 56
And water is 100 degrees Celsius, right?
Yeah.
So the difference is good. We can easily we can easily use some other method, right?
distillation.
So why did not we use distillation in that particular problem? Anyone?
Density difference.
No. What does distillation say? We can separate components based on boiling points.
Azeotropic.
Boiling points.
Azeotropic.
Who said azeotrope? Yeah,
Yes.
please. Who is this? Kalim.
Yes.
Yes, you are right. Acetone water forms azeotrope. I don't remember condition. Let's check. Acetone water azeotrope condition. So one of the reason to not go for no that this system inflection point of separation can be done, but an infinite number of stages are required. Okay, so this is difficult uh, with distillation. So we can go for liquid-liquid extraction. Okay, your answer is correct. But let's say I have benzene and water. Traces of benzene. I have huge solution of water. I have traces of benzene, and I want to remove that water benzene traces from water. So what should I do? Benzene and water, as far as I know, they don't form any azeotrope. So can we go for distillation for this particular example? Guys, please say something. Yes, no. We should not, right? Just to remove benzene or to vaporize water, we will have to give huge amount of energy. Because
Yeah,
it is based on this,
for
based
the
on
least cost,
boiling. Yes, it is
it is
based on
possible.
boiling point. So we will have to give huge amount of energy, and it is not feasible to just remove some traces of water, traces of benzene from water, or the
Okay.
reverse, whatever it is. Okay. Okay, I guess we will need to catch some speed because we are supposed to end at 7:05 and we have more 40 questions. What is the
Okay.
role of settler in liquid-liquid extraction?
To separate
Yes,
the phases based on
based on the density difference. This is
density.
basically for separation of solvent and whatever is extracted with, let's say, acetone, water, ethanol. So for separation of acetone and ethanol. Okay,
Okay.
if it's attracting ethanol. If acetone is if ethanol is extracting acetone. Okay, the next question. The LLE is referred to the component being extracted, the liquid phase in which extraction occurs, the
B
process of
option.
distillation. It is not going to be answer and heat exchanger. Okay, so it is A or B. What should be?
B option. The
Yeah,
liquid
the
phase in
liquid
which
phase
salt
in
extraction
which,
occurs.
yes, in which extraction is occurring. So that is called solvent. Okay. What is the key factor influencing the number of theoretical stages in distillation column? Feed
Reflex ratio.
composition, reflux ratio, tray diameter, or tray spacing, reflux ratio, right? So can anyone tell me when in shortcut design, is N and R related or not? Number of trays and reflux ratios are related or not?
Yes, number of ratio. They are inversely proportional.
Okay, so and there is one FUG method is Fenske, Underwood and Gilland method. So in which equation we take care of number of trays?
Number of trays. Gill. Actual number of trays is on Gill land, and Underwood is for minimum number of stages, and the Fenske equation is for minimum reflex ratio.
I guess Fenske is for minimum number of trays.
Acha, okay.
Uh,
Minimum number of trays.
no,
Okay.
I'm also
Can
not
you
sure.
give me
Just okay. Let's check from here only. Fenske equation. It is for number of minimum number of trays. Yes, Fenske is for minimum number of trays. Underwood is, as you told, for minimum reflux ratio, and Gilliland is from these two we can get actual estimated number of stages, actual number of stages required, right? So you just Fenske is for minimum number of trays. Okay. So next question 41. Which parameter is crucial for designing an efficient liquid-liquid extraction process?
Solvent to feed ratio.
Okay. Solvent to feed ratio, or it can also be solvent flow rate. Both are dependent, I guess. Okay. Both answers are dependent. Solvent to feed ratio also and solvent flow rate also. And in a way, we are setting solvent flow rate, right? Okay, what does the term distribution coefficient refers to in liquid-liquid extraction? Is it ratio of vapor to liquid phase, ratio of solute concentration in two phases, um, temperature difference, and pressure drop? What should be the
Uh,
answer?
Tricky question. B.
Yeah,
Ratio of solute
yes.
concentration in the two phases.
Yes, so if we go for this, your acetone, water, ethanol example. So let's say, I'm not sure acetone is acetone should be solvent and acetone should be solvent. I don't remember which was the solvent. Acetone was solvent or ethanol?
Give me a second. I will open that assignment.
I assume that acetone should be solvent, not ethanol. We are supposed to separate ethanol water using acetone, as far as my understanding, but I'm not sure. So what we do, let's say we have one solvent reach phase. So solvent reach phase. Okay, let's first check, then it will be easier for me to understand, to explain. I can also check which assignment is that.
Assignment 9.
Okay, so what is the problem statement? Is it
Can I share my
okay?
screen?
Just leave that part. So let's just understand that we have one A and B. A is some solute, B is solvent. Let's say A and water, and we have B solvent. So I want to separate A from water using solvent B. So what should I do? So we use liquid-liquid extraction. So what does distribution coefficient say? What is the ratio of solute in that solvent reach phase divided by raffinate reach phase? That gives distribution coefficient. So higher the value of distribution coefficient, better it is. That says that based on the ratio how we are defining it. Let's say it is based by extract by raffinate. So the more amount it is present in extraction phase, it is better. Which of the following is a common solvent used in gas absorption?
Water.
Which Aspen Plus tool is utilized for designing and simulating absorption? Very easy.
Absorb.
Absorb. The primary purpose of heat exchanger in Aspen Plus is also very easy. What do we do when the word name itself says heat exchanger? Exchanges heat. So it is
Heat.
transferring heat between two process streams. Then what type of heat exchanger is commonly modeled in Aspen Plus? We commonly model
Shell and tube.
cell and tube. Then how can you estimate the reboiler and condenser duties in Aspen Plus? Okay, one option is we can give reboiler duty as user defined. We can specify reboiler duty, right? But let's
Yeah,
say if we
it's
are not specifying, then it will be based on energy balance calculation,
energy
right?
balance.
We'll be writing energy balance across all trays 1 to 15 and one energy balance for last rate, that is, if we go for bottom last rate, that will also contain equation containing QR reboiler duty. On top it will be one equation containing heat duty in equal to out containing Q condenser. So from there energy balance equation we can estimate if we are not defining it. You compare two simulations for the same separation with the different ray efficiencies. Okay, two simulations for same separation. Let's say ethanol water separation. I'm using two separation with different ray efficiency. So what is true? Higher efficiency. If I have higher efficient ray, we require lower number of stages. If higher efficiency we have, we can get higher product purity. And if we have higher efficiency, we will require lower energy consumption. What is true? Or all of these are true?
All of these are
All
true.
of these are true. If it's higher efficiency means there is proper vapor liquid equilibrium on each tray. So if vapor liquid equilibrium is very efficient on each tray, we won't require additional trays to get actual vapor liquid equilibrium. Then if we are getting good vapor and liquid equilibrium, we'll have higher purity. And if these two are, if these number of stages are less, then we will have lower energy, right? So all these are correct. What is the effect of increasing reflux ratio on purity? No change, decrease, increase, or depends on feed composition. It increases, right?
Increases.
What does we do in reflux? We remove some distillate and most of the liquid we fed that back into distillation column. So what is happening? We are increasing the value of liquid holdup. So because of that, VLE will
It
be good and we will get more or higher amount of purity. If you go for MESH equation, mass equation for distillation, you will see there is one term M, that is holdup. So increasing reflux means increasing purity. How can you diagnose and troubleshoot flooding in packed column? It is asked for packed column. You are already you are already in a plant where there is a packed column and there is a flooding operation. So what will you do? What will you first check? Will you check liquid holder? Will you increase pressure drop? Will you reduce packing density? That I guess it won't be in our hand at that moment. And we'll use a different packing type that won't be at our hand at that time because the system is already running. So how will you diagnose it or how will you troubleshoot? We will check liquid holdup on each stage.
will
If
hold.
liquid
Yes.
holdup is higher, then that particular, let's say if this is one tray, these two, if the liquid holdup is completely, this tray is completely full, what will happen? It will go to below tray. So that is already flooded. So tray is called flooded. So we'll check liquid holdup on each stage. In the, sorry. Okay, in the properties environment, which among these are options in analysis object manager? We have PT envelope, right? In analysis part, if you remember here, sorry, here properties environment. If you go to analysis, what options we can see? We can see pure binary mixture solubility, PT envelope, ternary diagram, and residue curve. So answer should be PT envelope, right? Okay. While analyzing PT envelope, which of the following may be specified? What should be specified? Hello? Because we are supposed to specify valid phrases. I just request all of you, please check this answer. Please check this question again with Aspen Plus and let me know. As far as I know, it should be valid phrases. Okay. 53. Binary analysis can be done with more than two components. Is this true or not? The name itself says it's binary.
Yes, true.
True or false? More
Can
than
be
two
done with
components.
binary analysis, not more than true. Not more than true.
Okay. How many components need to be specified for ternary system? For ternary
Three.
map? Three. True. Are you following or not? You are not responding. Okay. What options are available in selecting valid phases for generation of ternary diagram?
Mm.
It is
This is
vapor,
tough.
liquid, liquid.
Acha, okay. This is
So
tough.
what did you
We
say?
done it. We have done it, but we don't remember now.
Okay, just check it. It should be
Yeah.
vapor, liquid, liquid.
Okay.
DKMA database, just like NIST, is freely available for Aspen
False.
users.
It is
False, it's not
paid.
freely available. It is
It's a
paid.
paid.
Reactor simulation may be performed by
Uh, Simulation, both these last two options perform reactor simulation.
yes,
Equivalent gives
equivalent games. Equilibrium based model equations are used in
Gibbs.
Gibbs. What does it do? It minimizes Gibbs free energy.
Gibbs free energy.
It finds the minimum point. In Aspen Plus, which unit operation is typically used to model a catalytic reactor?
Plug flow reactor.
It's a catalytic reactor. So in that, if you remember that LHSW problem that we solved, we defined catalyst density and bed
Yeah.
voidage. So it is for arc plug. Which of the following is or are not pressure changer models?
This question is little difficult.
No, it's not
Which are
difficult.
not?
Pump is
R compressor and M pump.
M pump. Okay. There is nothing called R comp. It is just comp. COMPR.
Yeah. It is only come and
Next is okay. And it is
uh,
M pump. There is nothing called M pump.
M pump.
Okay. R stoic block can be used where reaction kinetics are known but stoichiometric is unknown.
No, false. A
We,
stoichiometric
we
is
were supposed to define stoichiometry.
yes.
The model block HX flux is used to calculate
Uh, Overall heat transfer coefficient.
heat flux. Yeah, similar.
It should be
Heat
like
trans.
what should I write? Heat flux
Yeah,
or
heat flux, heat transfer flux.
heat transfer?
Which of the following is not a valid specification for distillation column in Aspen Plus? What do we not specify?
Tray
Number of
diameter.
trays, reflux ratio. In our normal design, we don't specify tray diameter.
Tray. Yeah.
A distillation column in Aspen Plus separates ethanol from water. The feed stream contains 58% ethanol. What properties should be specified in feed stream? For simulation, pressure, temperature, molar flow rates, or all of the above?
All of that.
Yeah, we should be in feed stream. We need to define temperature, pressure, molar flow rate, and composition. Right. In Aspen Plus, which method is typically used for rigorous calculation distillation column?
Red frac.
Rigorous calculation, yeah, red flag. DSTW is based on shortcut method, that is Fensky Underwood Gilliland method. Okay. Which component in Aspen Plus is used for initial simple distillation column design and rating?
DSTW. You.
Yeah, from DSTW, we get minimum number of trays, minimum reflux ratio, and actual number of trays, and that we give as input for red flag. So for simple initial calculation, we should go for DSTW. In a red flag column, what does the setting condenser type to total imply? Is it only partial condensation? Sorry.
Total condensation of vapor
Yeah.
leaving the top stage.
Yeah, so it will be completely converting it into liquid. Total. Total means completely condensing. Name itself says it. Which of the following is not a typical output from DSTWU simulation? Is it, I already told this, minimum number of stages, optimum feed stage, total annual cost, or minimum reflex ratio? So what do we not get?
Total annual cost.
Yeah, we even get this feed ratio, feed stage, NF by N, okay, feed stage. What is the role of convergence section in red flag column? To specify number of stages, to adjust operation parameters like pressure temperature, to set the criteria for solving columns material and energy balance, and to define feed and product stream composition. What should be the answer? If you remember, you are getting some errors like there is mass balance error of 0.001 10 is to minus 2. That is based on convergence. So what does that do? That is the criteria for solving material and energy balance. If you write your own code instead of doing in Aspen Plus, okay, I have written my code for reactive distillation column. So in that, when I was using Euler method to solve the column, we need to define some convergence. So after, let's say, third or fourth digit, if there is a difference, we will not consider it. That is not, that is nothing, but it's a convergence criteria. Okay. What is the primary
Option will be
C? Option C.
to set criteria of solving the columns material and energy
Yes.
balance.
That's
Okay.
why you sometimes see the error like
There is a
block is
convergence.
not in mass balance. There is some convergence error. You are getting some mass flow in and mass flow out is not. Let's say it's difference in third digit. So that is nothing but it's a convergence criteria set it. Okay. What is the primary purpose of R Gibbs reactor model in Aspen Plus?
B option to simulate
Yeah, we
reaction based
already
on
discussed to simulate reaction based on the minimum Gibbs free energy. In Aspen Plus, what parameter is crucial when configuring an absorber column for removal of CO2 from natural gas using aqueous amine solution? What should be the answer?
flow rate of amine solution
Yes,
since it
because we want to absorb CO2 from natural gas into amine solution. So we should play with flow rate of amine. So it's a crucial parameter. Okay, what is the significance of using a rate-based model for absorption column? Does it only considers equilibrium stage? It simulates mass transfer as well as reaction if it's happening. It is used for binary system and it estimates only the temperature profile. What is the answer? It is clear. It is saying rate based. It is detailed mass transfer with reaction. It is there is mass transfer as well as reaction. For that
okay.
rate based model is used. So answer should be B. Okay, what is the role of lean solvent in context of an absorption unit operation unit process for gas treatment? What does the lean solvent mean? This is not Aspen question. This is more of a basic question. So it is the solvent that has been regenerated and contains little absorbed solute. Let's say I have CO2 absorption from natural gas using amine solution. So amine will absorb CO2. Now we need to regenerate amine solvent. So for that, we will use some stripping unit. So most of the CO2 will be removed, but some amount of it will be there. So that is nothing called lean. That is nothing, but it is called a lean solvent. So the answer should be B. It is the solvent that has been regenerated and still it contains little absorbed solute. What is
Okay.
the primary goal of performing sensitivity analysis?
To determine the optimal size of equipment to use.
Option 1 is to determine optimal size, to understand how changes in process variables affect the outcome of simulation, to
B option.
minimize. Option B, we check that, let's say I want to increase the purity. So we don't know what do we do. So we just said that we want to see the effect of some temperature on composition. So this is how changes in process variable, let's say temperature, that affects the outcome of simulation. Let's say how temperature is affecting our product composition. So the answer should be to understand how changes in process variables affect the outcome of the simulation. In the sensitivity analysis, what type of variables are typically modified to observe different responses? Do we play with only temperature, pressure? We can play with any input variables such as flow rate, temperature, pressure, composition, only catalyst amount, reaction times, or only composition of feed stream. What can we play with?
B option.
Yes, even all these, not if it's not written only temperature and pressure, that is also correct. If it's not only what, catalyst amount is also correct and composition of feed stream is also correct, but they are writing only. So that's why it is wrong. When performing sensitivity analysis on a distillation column in Aspen Plus, which parameters might be commonly varied? Let's say I am doing for distillation column. So what will I be varying?
B
To
option. Reflect ratio,
option B,
field
we will be
location.
varying reflux ratio, feed location, and number of stages to see what is the maximum purity or whatever we are seeing to get maximum value. Okay. In Aspen Plus, how are design specifications used in the simulation? To calculate total cost, to ensure simulation converts it properly, to constrain values of certain variables, and to generate random inputs from sensitivity analysis.
Design specifications. It should be B option.
It is option C. Let's say I
C.
want to, let's say I perform sensitivity analysis by varying temperature on feed composition. Now let's say I want exact 98% purity. So that is the constraint. Okay. So we are constraining that I want purity, let's say 98% only, 0.98. We solve this problem. So
Yeah,
in that
yeah,
we gave some value. So we are constraining the values of certain variables in the model,
model.
right?
Yes, we need to yeah.
Answer is C. Okay, which property method in Aspen Plus is commonly used for non-ideal liquid mixers?
And liquid is NRTL.
Yeah, it is. Wilson is also non-ideal model, but Wilson is not commonly used. NRDL is commonly used. Okay, last two questions. Which property method in Aspen Plus is commonly used for electrolyte solution?
This
It
is
is
tricky.
Debye-Hückel. That is
Okay,
Debye-Hückel. If it's
okay,
ENRTL, then it is for electrolyte solution.
okay.
The
This is
last
tricky.
question. Okay, last question. In Aspen Plus, how does the property method affect the accuracy of simulation results? Option A says it has no effect. Option B, it significantly impacts accuracy, especially for non-ideal systems. It only affects temperature and pressure calculations, or it affects the speed of convergence, but not accuracy. What should be
Property
the
method accuracy, especially non-ideal. B option.
we if we remember that problems that when we did benzene toluene, we generated XY data and we match with ideal. So it was matching. But when we did the same process for ethanol water, it was not ideal, was not matching with experiments.
Yeah.
So that is impacting it significantly impacts the accuracy, especially for non-ideal system, because for non-ideal system, there will be deviations because of
Yes.
interaction. Okay, so this is all from my side.
Okay.
So I'm done from my side. All the best for your
Okay.
examination.
Okay.
And if you have something to ask, please feel free to write me. I will try to
Okay.
solve.
One question is there. Can I share
Yes,
my
please.
screen?
Yeah, please do it. Okay,
Yeah,
wait,
last.
just let me just stop the recording. Thank you all for joining.